Okay, good morning. So let us solve the problems in homework 1. As I told you, the homework problems are usually a little bit advanced problems at the level of national exams. So I really recommend you try to think about them. So another one is published. This is closed now. So you can start working on the other one immediately after the lesson is finished. So let us try to solve them. So let p of x be a second degree polynomial. So let me read the problem here. Let p of x be a second degree polynomial with these conditions. We know p of minus 1 is 0. We know that p of 0 is 5. And we know that p of 2 is minus 3. The sum of the squares of the coefficients of p of x is equal to the number that you are supposed to put here. Okay? So how should we solve the problem? I don't say that this is a hard problem. It's a very standard problem. Okay? So the first part of the question is telling you that p of x is a second degree polynomial. Which polynomial is that? I don't know, but I know something. I know a second degree polynomial in general has this form. Yes? When you say that p of x is a second degree polynomial, and I don't say more, in general, p of x is this. And then you see how many unknowns are there. If I ask you to fix p of x, you have to find a, b, and c. So you are facing 3 unknowns here. And how many pieces of information is provided for you? Exactly 3 pieces of information. So that is the way that you need to think. 3 pieces of information is useful when you want to find 3 unknowns. So everything fits. The reason that I'm talking about these things because I want you to get the feeling, yes? Okay, so now let us use them one by one. The first piece of information tells you that p of minus 1 is supposed to be 0. So what does it mean? It means that if you go to your polynomial, replace x with minus 1 everywhere, the input is minus 1, the output is 0. So what does it mean? It means that if I go to my polynomial, replace every appearance of x with minus 1, the output is supposed to be 0. On the one hand, this is my output. On the other hand, 0 is supposed to be the output. So this means that they have to be the same. Yes? And I do a little bit of simple things. Okay, so p of minus 1 is 0, I get this one. But of course I simplify that. No one writes minus 1 squared, because minus 1 squared is just 1. 1 times a is a. b times minus 1 is simply minus b, and then c is equal to 0. This is one thing that I want. But I know that this is not enough yet, because I have 3 missing pieces. This is just one equation. And then you understand what is the rest of it. The rest of it is p of 0 is 5. So what does it mean? It means, let me repeat once more. It means that if you go to p, replace x with 0 everywhere, the output is supposed to be 5. So I do it. I go to my p, I replace every appearance of x with 0. This is the output on the one hand. On the other hand, the output is given to you. So these two outputs should match. Understandable? But this is extremely simple because 0 squared is 0 times a is 0, b times 0 is 0, so nothing so far. And then I am left with what? C on the left. I am left with 5 on the right. Okay, good enough. Actually, I found C to be 5. Yes? And then I use the other one, which is what? P of 2 is minus 3. I will do the same thing. So I replace every appearance of x with 2. Yes? The answer is supposed to be minus 3. This is simply 4a. This is 2b. And then we found c. What is c? 5. If you don't mind, let me write it down. Okay, it's minus 3. Because sometimes the problem is not simple. You have to solve the equation. You still have to solve the system of equations. So I am looking for three numbers satisfying these three conditions. If you remember from Ma3c, it's called the system of equations. Three unknowns in three equations in three unknowns. So one equation is 4a plus 2b. You don't need to write so much. You can immediately replace c with 5. I'm intentionally not doing that because it was a coincidence that I got a simple equation like this. In general, I get three equations. So you need to know that you have to solve the system. Yes? This system is very easy to solve because one of the unknowns is already found. It's 5. I put 5 here and there. Okay? So can you do it in your head? If I put 5 here and then move 5 to the other side, so it becomes 4a plus 2b, and then this is minus 3, 5 is here, I move 5 to the other side, it becomes minus 8. And I also have c5 here, so it becomes a minus b. I move c to the other side, c is 5. When I move it to the other side, it becomes minus 5. So my equation, I had three equations in three unknowns. Now I have two equations in two unknowns. Even in Grundschule, you have studied how to solve that problem. That's up to you how you want to do it. For example, you can divide everything by 2 and add them up. Or if you want, you can multiply this by 2 and add them up. The point is to get rid of one variable at a time. I don't know which one you prefer, so let us just multiply this by 2. Okay, can you do it in your head? I multiply by 2 everything and then add this to this equation. 2a plus 4a becomes 6a. 2 times minus b is minus 2b, and that was the reason I multiplied by 2, anticipating that minus 2b, when added to 2b, they are gone. Okay? And I have to do the same thing here. 2 times minus 5 is minus 10. Minus 10 added to minus 8. What is the answer? Minus 18. I am looking for a, so I have to isolate my a. I divide everything by 6, it becomes minus 3. So the second unknown is also found. I know c, I know a, I can find b. I would prefer to use this equation because it is simpler in form. Instead of a, I put minus 3, b is still missing, and then I can immediately find b. So what is b? What is b? 2, yes? So what is the mathematical name for a, b, and c? Coefficients. And let us go back to the question. What this is asking us, the sum of the squares of the coefficients. So the question mark is what? The question mark is the sum of the squares of the coefficients. It means a squared plus b squared plus c squared. Everyone understands? This is what the question asks for. The sum of the squares of coefficients. So a squared is 9 because a is minus 3 squared is 9. B is 2, so it becomes 4. And finally this one is 25. So if we add them up, 9 plus 4, 13. 13 plus 25, 38. This is the number that you're supposed to type in that empty space. Okay? So that's the solution of the first problem. This is an A-level question, but you see it is not hard. Okay, the exam for homework 2 is a little bit harder, okay, but you already have some experience, so it is not hard. Any questions here? Yes?
My question is, how can you assume that the second degree polynomial is always ax squared?
No, it is always. We discussed about that.
Yeah.
The second degree polynomial is always in the most general cases of this form.
Yeah, but wouldn't it also be like ax squared plus c? It could also be like that.
Okay, but that is a special case of this one. If you choose, that's the point. But you cannot assume this from the beginning. Because if you assume this for your quadratic polynomial or second degree polynomial, it means without any calculations, you are assuming b is 0. If b is 0, this turns into that. But when they say I have a second degree polynomial, nothing else, you are not allowed to assume this, because assuming this means that somehow you know the middle term is 0, but there is no reason to believe in that. Yes? So you have to start with the most general case. If they say that I have a third degree polynomial, in principle you can write like this. This is a third degree polynomial. But you're not allowed to assume that. You have to assume that ax cubed plus bx squared plus cx plus d. Unless you have a reason not to do that, which we don't have here. Yes? Yeah. Any questions? Yes?
I don't know if it's a mistake, but I did this a little bit different.
Yes?
Instead of multiplying by 2 and then adding together, I just defined a by moving over.
Yeah, that's all. The way that I did it is called addition method. The method that you are doing is substitution method. No, it doesn't matter. So don't worry about these differences. If this is completely valid, you will get the points. Even if in the beginning they have mentioned the other way, I can see it. If that's valid, I will give you the points. Yes? Okay. Any questions? Okay, let us go to the next problem. Okay, so here it's a little bit harder. But this is one, might be, I am using this as an excuse to teach you how to do this. Again, number 2, let p of x be a quadratic polynomial. I am playing with these words so that you also learn. Second degree polynomial means the same thing as quadratic polynomial. Yes, so remember these words. So let p of x be a quadratic polynomial such that x minus 1 times p of x is equal to x cubed plus x minus 2. The sum of the coefficients of p of x is equal to this. Okay, one thing that I want you to know, when they say that this equality holds, okay, it means the equality holds for all possible choices of x. Okay? It is very important. This is not an equation. You are not supposed to solve this and find x. This equality, according to the claim of the problem, is valid. When you say this equality is valid, it means for every choice of x, the left-hand side is supposed to be equal to the right-hand side. Okay? This is very important. I will use that. But the rest of the problem, the starting point is the same. So let me write it here for you. So again, p of x is a quadratic polynomial. What does it mean? It means p of x is equal to ax squared plus bx plus c. Still, we don't know what it is. But I know something. I know if I multiply x minus 1 by my polynomial, it is always equal to x cubed plus x minus 2. Okay, so let me do the calculation. This is what I understand because p of x is a quadratic polynomial. This is given by the problem, so I combine these two into one line. How? By taking this out and putting this instead. Okay, x minus 1, ax squared plus bx plus c. And then the right-hand side is this one. Okay, is that understandable? Okay. Of course, in principle, I want to teach you this today, but I hope that you don't have any problems with multiplying this by that, yes? This is a recap from Ma3c. Do you know how to multiply this by that, yes? So you have to take x, multiply it here, here, and there, and then take minus 1, do the same thing. Okay, so that is actually the lesson today. I don't know why they repeat it again here, but we follow that. So I multiply this, it becomes ax cubed, and then this multiplied by that, it becomes what? Bx squared, multiply x here, it becomes cx, then I multiply minus 1 here, here, and there. So it becomes minus ax squared minus bx minus c. This is supposed to be equal to this. Okay, again, I am repeating this. This is not an equation. I am not looking for x. Okay? I am trying to fine-tune a, b, and c so that the left-hand side becomes identical to the right-hand side. So I have to write the left-hand side in a way which is comparable to this one, so that I can compare them term by term, because I want to make them identical. Okay, if you look at the left-hand side, the highest power, which is the degree, is this one, and this is alone. There is no cubic term here. So I will write this one. But how many square terms you see? One of them you see here with x squared, another one you see here, an x squared. I want to write it in one location. I want to have only one x squared somewhere. Okay? You will see why. So what is the then? What is this? What is the way that I have to do it? I factor x squared out. From this one, b is left. From that one, minus a is left. Okay? For the time being, concentrate on to understand that this is valid. Yes? You might not appreciate yet why this is good. You will see it later. But for the time being, this is a valid way of doing this. Yes? Because if I multiply this back, it becomes b squared. That's correct. If I multiply this back, I will get this one. That's also correct. So I haven't done something illegal. Yes, that's valid. Okay, and then how many places you see that I have x involved? 2 places. Yes, one of them here, the other one there. So can you guess what I'm going to do now? The same thing, I factor x out. So I put an open pair of brackets here. I pull x out. What is left from this guy? C minus b. And this one is left alone. Yes? And the right-hand side is x cubed plus x minus 2. Be careful again. You are not supposed to look to find x. Your goal is not to find x. Your goal is to fine-tune so that the left-hand side matches with the right-hand side for all choices of x. Okay, so when this happens, it means that you want to make this to be identical to this. What do? You see that a is the coefficient of x cubed here. The coefficient of x cubed is how much here? 1. So I choose myself a to be 1. My goal is to make the left identical to right. So here, if I ask you what is the coefficient of x squared, what the answer is? b minus a as a whole is the coefficient of x squared. Okay? But what is the coefficient of x squared on the right? 0. There is no x squared there. So it means that I have to get rid of this term. So b minus a should be 0. Now, if I ask you what is the coefficient of x term, c minus b, what is the coefficient of x term there? 1. So c minus b should be 1. And the constant term without x on the left is minus c. The constant term on the right is minus 2. So you see what I'm claiming. I want you to understand the logic. I want to understand that if I choose these cases, then you agree with me, the left-hand side matches with the right-hand side identically, no matter what choice of x is. Is that right? And that is the whole point. Equality between polynomials doesn't mean an equation. It means identity. We want to make the left-hand side identical to the right-hand side. Is that right? Okay. And then it is extremely simple now, because now I have a system of 4 equations. A is 1, c minus b is 1, b minus a is 0, and minus c is minus 2. This system is a little overdetermined, meaning that you have only 3 unknowns, but you have more pieces of information. So the information should be consistent. You have to check that out. But a is already 1. Immediately I understand that b and a are equal. If a is 1, what does it mean? b is also 1. c is what? 2. Yes? So I found that. And be careful about it. You might say that I found all my answers. One of them I didn't use at all. Which one? C minus b is equal to 1. I didn't use it. Be careful. If you don't care about that one, you might fall into a trap, because you have to check that the answer is also consistent with what you haven't used so far. Is it consistent or not? Let us check. C is 2, B is 1, so 2 minus 1 is equal to 1. True or false? True. So this becomes true. This is important, even if you didn't care about this, your answer would have been correct. But mathematically and logically, you have to check that one as well. For example, let us say this is 5. You found these answers, you think that you found the answer, but when you check it here, if it is 5, the answer becomes false. Okay? And then what will be the answer to the problem?
False.
No. It's grammatically wrong, yes? What is the answer to the problem? The answer to the problem is this. There are no quadratic polynomials that fits this equation. Okay? So be careful about the interpretations. Here, the problem, I could have chosen the numbers in a way that if you didn't care about this, you would have answered that, and that would be wrong. But my question is that because here I have 4 pieces of information, I only used 3 of them and found all answers, you might think this is redundant. This is not redundant. That should also be checked, and it should be consistent with what you have got so far. In this case, it is, so these answers are acceptable. If it is not, the interpretation is important. The interpretation is that no one can ever find the second-degree polynomial that fits this equation. Because fitting a second-degree polynomial in this equation gives rise to inconsistency, and this is not possible. But anyway, for this problem, it is working, and what do I want? The sum of the coefficients. Well, it's very simple. So what is the question mark? A plus B plus C. A is 1, B is 1, C is 2. So the answer is 4. Any questions? Yes?
How did you get that C minus B is equal to 1?
No, C minus B is the coefficient of x term. Yes? What is the coefficient of x term there? 1. So C minus B should be 1. Otherwise, they cannot be the same thing. They have to be identical. Yes? So what I'm doing, I multiply and arrange the left-hand side as a standard polynomial and compare it with the other polynomial, coefficient by coefficient. That is the trick. Okay, so you need to learn that. Yes, please?
I'm just wondering, how did you read the coefficients? Like, how did you K?
No, the coefficient is the number. This is the definition of a coefficient. A number that is sitting to x cubed is the coefficient of x cubic term. The number sitting here is x squared, but the problem, I cannot say the coefficient is b because still x squared is in 2 places. If I want to read the coefficient of x squared, I have to have x squared in one location, in one place. So I have it in 2 locations, so I factor x squared out, then I will have a cubic term, a term with x cubed, and now I have one single quadratic term, a term with x squared. Yes, and this is, next to it is called the coefficient.
How did you get that to 0?
Okay, because on the right-hand side, if I ask you what is x squared term here, you see only x cubed, you see x, but you do not see x squared. Yes? So this means if you do not see x squared, you have to fine-tune them in a way to help you to get rid of x squared because you don't want to have it. The only way that you can do it is to put this equal to 0 so that you can get rid of it. Yes? So the recipe is this. Organize the left-hand side as a standard polynomial and compare it coefficient by coefficient to the right-hand side. And you get a lot of equations and then try to solve those equations. Yes? Understandable? Okay. So after the lesson, I will publish this. Any questions? Understandable? Okay, so thank you for this.